take a look at some types of partial fractions and how we actually carry out integration using partial fraction method. The four rules or main types of partial fraction integration we will look at are, first of all, non-repeating linear factors, then repeated linear factors, then non-repeating quadratic factors, and finally there's a fourth one, repeating quadratic factors, but we will cover three in detail in this video. Some useful facts that you should note is that the integral of du over u is equal to ln of the absolute value of u plus c, and the integral of du over u squared plus a squared is equal to 1 over a tan inverse u over a plus c. Now, in the more simpler form of this, we could find something like the integral. Let's see if this is getting some traction here. Integral of 1 over 1 plus x squared, or if you had x squared plus 1, that's fine, dx is going to be tan inverse of x plus c, right? That's a more simpler way of this same particular du over u squared plus a squared is equal to 1 over a tan inverse of u over a plus c. All right, so that is it for that. Now, another thing that may happen is that the numerator may turn out to be the derivative of the denominator. In this case, we have something like the integral of f prime of x over f of x dx. The solution to this will be the ln of f of x, which would be a denominator, plus c. Let's look at a couple of examples. First one, we write 6 minus x squared over x bracket x squared plus 5x plus 6 close bracket as a over x plus b over x plus 2 plus c over x plus 3. Find the values of b and c, and hence determine integral of 6 minus x squared over x bracket x squared plus 5x plus 6 close bracket dx. Now, let us go right back up there where we were. And let's start doing the partial fraction decomposition of 6 minus x squared over x bracket x squared plus 5x plus 6 equal to a over x plus b over x plus 2 plus c over x plus 3. And the one way of doing that, you can multiply each term by the common denominator, which is x bracket x squared plus 5x plus 6 close bracket, and clear the denominators. When you do that, you will have 6 minus x squared is equal to a bracket x plus 2 close bracket open bracket x plus 3 close bracket plus bx in brackets x plus 3 plus cx in brackets x plus 2. Of course, you could have done the a plus b plus the c part by just looking at the LCM and then doing your conversion equivalent fractions type of stuff, and you still end up with the same kind of answer. So now we want to find each of a, b, and c separately, and because all of these have linear factors, we can use something called our linear denominators. You can use something called the zero-in method, where you set the x values equal to each of the numbers that goes along with the x that would make it equal to 0. So because we have an x plus 2, in order to make that a 0, we have x equals -2 to 0 out the x plus 2. So if we let x equals -2 and put in -2 for x throughout everything, it'll be 6 minus -2 squared. That's going to be equal to a times -2 plus 2 times -2 plus 3 plus b times -2 times -2 plus 3 plus c times -2 times -2 plus 2. And so you will have 6 minus 4 is equal to anything with -2 plus 2 will drop to 0. So the a times the -2 plus 2 times the -2 plus 3, that drops to 0. Then the b times -2, that's -2b, and -2 plus 3, that gives you 1. So that's going to be 1 times -2 times b, that's -2b, plus, again, you see a -2 plus 2, we have a multiplication by the c, so that gives you a 0. So then 6 minus 4 is 2, and then 2 is equal to -2b. We divide both sides by -2, you have b is equal to -1. Now I want to make x equals -3 to get rid of the x plus 3 term. I'll let that be 0. So we have 6 minus -3 squared is equal to a times -3 plus 2, -3 plus 3, that will drop to 0. And b, -3 times -3 plus 3, that drops to 0 as well. Plus c times -3 times -3 plus 2. And so on the right hand side I have 6 minus 9, on the left side 6 minus 9, on the right side 0 plus 0 plus 3c. So 6 minus 9, that is -3. -3 is equal to 3c. Divide both sides by 3. Have c equals -1. Then we let x equal 0. And 6 minus 0 squared, that gives you 6. On the right hand side, a times 0 plus 2, that's 0 plus 3, so that gives you 6a. But b times 0, that gives 0. C times 0, that gives 0. So 6 equals 6a, divide both sides by 6, a equals 1. So then 6 minus x squared over x bracket, x squared plus 5x plus 6 is equal to 1 over x minus 1 over x plus 2 minus 1 over x plus 3. Replacing the a, b, and the c with the corresponding a equals 1, b is -1, and c was -1. Now the integral of 6 minus x squared over x bracket, x squared plus 5x plus 6 dx is going to be equal to the integral of 1 over x dx minus integral of 1 over x plus 2 dx is missing there, and then minus integral of 1 over 3x plus 3 dx. And since these are all linear denominators, the integrals, we're going to use rule 1. So that's going to be equal to ln of x minus ln of x plus 2 minus ln of x plus 3 plus c as your answer. Example 2. Given 2x minus 3 over x squared plus 1 times x is equal to ax plus b over x squared plus 1 plus c over x. So notice that's a quadratic factor there, x squared plus 1, which is irreducible. So that is why your decomposition is like that. Find the values of a plus b and hence determine integral of 2x minus 3 over x squared plus 1 times x dx. So then we begin by saying 2x minus 3 over x squared plus 1 times x is equal to ax plus b over x squared plus 1 plus c over x. Again, if we multiply everything through by the common denominator, we will have 2x minus 3 is equal to a plus b bracket x plus c times x squared plus 1. Expanding the right side, 2x minus 3 is equal to ax squared plus bx plus cx squared plus c. Then that simplifies 2x plus, that should be minus 3 right here, not a plus 3, minus 3. It's equal to ax squared plus cx squared plus bx plus c. That simplifies to give a plus c in brackets x squared plus bx plus c, and then equating coefficient. There's no x squared term on the left side, so that's going to be 0x squared. It's going to be equal to a plus c x squared on the right. So if you continue setting that equating the coefficients, or if you say dividing through by x squared, you have 0 is equal to a plus c. So then we could say a is equal to negative c. Now on the left side, the coefficient of x is 2. On the right side, coefficient of x is b. So 2x is equal to b, dividing both sides by x. We will have b equals 2. The constant term negative 3 is equal to the constant term on the right side, that is c. So c is equal to negative 3. But we know from step 1 that a is equal to negative c. So a will be equal to the negative of negative 3. So a is equal to positive 3. So then 2x minus 3 over x squared plus 1 times x is equal to 3x plus 2 over x squared plus 1 plus negative 3 over x. And so the integral of 2x minus 3 over x squared plus 1 times x dx is going to be equal to the integral of 3x plus 2 over x squared plus 1 dx minus integral of 3 over x dx. Now we can split the 3x plus 2 into 2 fractions because it's over the same denominator. So that's going to be integral of 3x over x squared plus 1 dx plus integral of 2 over x squared plus 1 dx minus 3 times the integral of 1 over x dx. Now if you notice, the denominator x squared plus 1, the derivative of that will be 2x. So if we pull out the 2x from the top, we're going to have a 1.5 from left off as a product. So 1.5 times 2, that would be give you 3. So we factor out a 1.5 out, and so that becomes the integral of 2x over x squared plus 1 dx plus 2 integral 1 over x squared plus 1 dx minus 3 integral of 1 over x dx. And then by rule 3, our answer is 3 over 2 ln of x squared plus 1. And then by rule 2, it becomes a plus 2 tan inverse of x minus rule 1, because x there is just a linear. So that's going to be 3 ln x plus c. Our final example 3, we're asked to rewrite 3x minus 1 over x squared minus 4x plus 4 as a over x minus 2 plus b over x minus 2 squared. Find the values of, that should be a and b, and then hence determine 3x minus 1, 3x minus 1, x minus 1 over x squared minus 4x plus 4. And so we said 3x minus 1 over x squared minus 4x plus 4 is equal to a over x minus 2 plus b over x minus 2 squared, multiplying through each term by the common denominator, or the LCM, gives 3x minus 1 is equal to a times x minus 2 plus b. And so 3x minus 1, if you distribute the a through, becomes equal to ax minus 2a plus b. And then equating coefficients on the left and right, 3x will be equal to ax, which means that you divide through by x, a will be equal to 3, and negative 1 is equal to negative 2a plus b, and then substituting in that 3 for a, negative 1 minus, negative 1 rather, equal negative 2 times 3 plus b. So negative 1 will be equal to negative 6 plus b. So if you add 6 to both sides, you have 5 equals b, or b equals 5. Replacing here a and b in the original. 3x minus 1 over x squared minus 4x plus 4 is equal to 3 over x minus 2 plus 5 over x minus 2 all squared. So the integral of 3x minus 1 over x squared minus 4x plus 4 dx is equal to 3 over x minus 2 dx plus 5 over x minus 2 squared dx. You pull out the constants outside, it's going to be equal to 3 times the integral of 1 over x minus 2 dx plus 5 times the integral of x minus 1 over x minus 2 squared dx. And if we use the rule 1 on the first integral, that becomes equal to 3 ln x minus 2, and applying a power rule of integrals, which was not listed in the rules in this class but was from a previous class, we'll have the second integral being negative 5 over x minus 2 and then plus 3. Thank you so much for watching.